Hi everyone! Today's lesson is about identifying the types of solutions. Let's go over with solving systems of linear equations when there is one solution, no solution, and infinitely many solutions. When there is only one solution, the slopes are different and two lines intersect at one point. If there is no solution, the slopes are the same and the y-intercepts are different. And two lines are not intersecting. That means they are parallel. If there are infinitely many solutions, the slopes are the same and y-intercepts are the same. And they overlap. That means they intersect everywhere because the lines are the same. Let's do some example problems. Find a solution of each system of equations below using any method, graphing, substitution, or elimination. State the number of solutions and describe the graph of each system. Our first system is 2y is equal to x plus 2, y is equal to 1 over 2x plus. I am going to use the graphing method for the first system. However, you can use either substitution or elimination. I'm going to solve 2y is equal to x plus 2 for y. I'm going to divide every single term by 2 to isolate y. Then we will have 1 over 2x plus 1 for the first equation. And I can identify slope and y-intercept for this equation. Now let's look at the second equation. I'm going to use another color. Interesting. So if you check carefully, you will see they have the same slopes and y-intercepts. So let's go back to the figure. We have here, if two lines have the same slopes and same y-intercepts, they intersect everywhere. That means the lines are the same and they have infinitely many solutions. Then we don't need to graph it anymore or graph them anymore. So we have infinitely many solutions here. And our lines are the same. Okay, let's continue with second system. I think it's better to use substitution method here because y is already isolated. So I'm going to start with substituting 2 times x minus 1 for y in the second equation. So here's our second equation. So I'm going to substitute 2 times x minus 1 for y. And I will rewrite the other side of the equation. Then let's distribute 2 over x and negative 1. And we can subtract x from both sides to isolate x. And add 2 to both sides. Okay, so we found x. Now let's substitute 3 for x in the second equation to find y. And we will have our solution as three, 4. So if we describe the graph here, we can say, let's go back up here, we have one solution only. It means we have two lines with different slopes and they intersect at one point. So intersect at one point. That means we have only one solution, and this is the solution. Okay, let's move on to the third system. Let's use the elimination method for this system. I will isolate the constant for the second equation to write the second equation in the standard form. So let's write it down, and let's subtract y from both sides. And then 4, which is our constant, will be isolated. And we will have negative x minus y on the right side of the equation. Now I can rewrite this equation in negative x minus 5 is equal to 4 format. It's the same thing. Let's rewrite the system. Our first equation was x plus y is equal to 5. And our second equation is negative x minus y is equal to 4. So let's add them. Oh, our both variables are gone. And the statement we ended up with 0 is equal to 9, which is not a true statement. Then, because this is not a true statement, we will say no solution. If there's no solution, let's go back up here. If there's no solution, the slopes are the same and the y-intercepts are different. And there's no intersection point and the lines are parallel. So let's go back here, let's describe the graph. So we'll say no solution and the lines are parallel. Okay, we're done. Great job, everyone. Here is our final answer for the last system.